Welcome to Brain Science, the podcast where we explore how recent discoveries in neuroscience are helping unravel the mystery of how our brain makes us human. I'm your host, Dr. Ginger Campbell, and this is episode 177. Before I tell you about this month's episode, I want to remind you that you can find complete show notes and episode transcripts on my website at brainsciencepodcast.com. You can send me feedback at brainsciencepodcast@gmail.com, submit voice feedback at speakpipe.com/DocArtemis, and post to the Brain Science Podcast fan page on Facebook. Brain Science is independently produced and depends on listeners like you for financial support. To learn more about how you can help, just go to brainsciencepodcast.com/donations. This month's episode is a conversation with Bernaard, Baars, and David Edeleman. Dr. Baars began to develop his Global Workspace Theory of Consciousness back in 1980, when the study of consciousness was still largely considered taboo. He remains deeply fascinated by the question of how the brain creates consciousness, and he recently sent me his latest book, On Consciousness, Science and Subjectivity, which gathers much of his work on global workspace theory into a single volume. It was an honor to talk with him, along with his friend and colleague, David Edeleman. As always, I will be back after the interview to review the highlights and also to tell you about how you can be part of the webinar I'm hosting on November 17th, 2020, called Embracing Uncertainty: How to Thrive in an Uncertain World. Today, I'm welcoming two guests to Brain Science, Bernaard Baars and David Edeleman. I'm going to give each of you a chance to tell my listeners a little bit about yourself, starting with Bernie. Can you tell us how you got interested in consciousness at a time when it wasn't considered a proper subject for science?
Right, exactly. And this may be very hard for young people to understand, that there was a time, a very long time actually, in the history of American and British psychology and also philosophy, perhaps also some other sciences, where the word consciousness was taboo. And I sometimes compare it to sex in the Victorian era, because people know about that and have some conception about that. It is very hard to explain, but I had wonderful teachers, wonderful professors at UCLA as an undergraduate student, and they were all professionally constrained to talk in behavioristic terms, however that would be interpreted. And I now realize, much later, that they were probably very uncomfortable with it, because they realized perfectly well, of course, how profoundly important consciousness is in psychology. In any case, it was a time, you grow up at a certain time, you accept the taboos, whatever they are. And then after a while, I began to realize, without anger, without any negative feelings at all, because I truly had wonderful professors, I began to realize what everybody else also realized, that there's this profound dissonance between what we're allowed to say and what is really important in psychology.
William James, at least in the United States, is considered the father of psychology. And wasn't consciousness the thing he cared about?
He cared enormously and wrote what is still considered to be, I think, by far the best and most compendious book on consciousness, dated 1890, but a great deal of excellent science had been done by that time. And James had such an open mind. He was interested in hypnosis. He worked with Morton Prince on a woman patient who had a multiple personality disorder, and so on. So he was tremendously open-minded. However, he was also very troubled by what's called the mind-body problem, which is essentially a philosophical problem. And James had occasional depressions in his life that were quite intense. And he would tend to attribute his feelings of depression to his doubts about free will, which was a very emotional issue for him. So he was tangled up in certain philosophical questions that made it very hard to be purely naturalistic about consciousness.
Right, because he's also a very important figure in American philosophy.
Right. Right.
Well, we're going to come back to this some more. I want to give David a chance to introduce himself.
Thank you. Thanks, Ginger. So I have a really sort of weird and tortuous career that I'll give to you in a sort of a nutshell. I'm presently a neuroscientist. I'll be a neuroscientist at this point till I die, which I guess is a good thing. But I started off actually as a human paleontologist, or in more common parlance, a paleoanthropologist. I got my PhD in human paleontology at the University of Pennsylvania about 23 years ago. And at the time, I had sort of Indiana Jones sort of fantasies. Now, of course, Indiana Jones was an archaeologist, not a physical anthropologist, so I have to make that distinction. But I imagine myself with a fedora in the field, digging up profoundly strange and interesting bones and making sense of them. And since my stock and trade was human evolution at the time, I started off being very, very interested in the evolution of the human brain until I found out, to my dismay, that, well, I kind of knew this, but that, there's not very much left behind. We sort of end up with hard tissue, and principally the inner cranium, the hard shell that surrounds the brain. Now, that at some point was a combination of living tissue and inorganic material, but it left, by and large, the inner tables of cranial leave imprints of the brain that presses against them. So you can tell something from these sort of endocranial casts about how early brains were organized, not just in human ancestors, of course, but in certain non-human mammals. So I started off on that path, but I quickly realized that it was going to be really, really difficult to marshal a satisfying amount of evidence in that regard. So in the process of sort of realizing that this was not going to be terribly fruitful for me, I shifted gears and I basically rejiggered myself to study the evolution of bipedalism, the evolution of upright walking as a major adaptation in the hominine line leading up to modern humans. And so that was much easier. You could generate, I generated 535 pages worth of dissertation on that, worked out pretty well. Got out of graduate school, realized very quickly after a few short lists and a few canceled job searches that I wasn't going to get a job in physical anthropology. And so it was suggested to me that I do postdoctoral fellowships in harder science, as a certain relative put it to me. And so I did a postdoctoral fellowship in molecular and cell biology for about 3 or 4 years. And then I moved on to cellular neuroscience, and in particular, how the brain uses energy. And I studied these little sort of power cells in each eukaryotic cell and in each neuron, of course, called mitochondria, and how they move about and how that sort of dictates or limits brain activity, because it really, really does, although we don't understand quite the means by which this happens. So this was really intriguing. And then Baars came to the institute where I was a postdoc and then sort of an early career researcher. And Bernie and I started having sort of luncheons. It was a standard practice at the institute to have Monday lunches. So Bernie, myself, and a fellow named Anil Seth, who's at the University of Sussex, started eating lunch together. We more or less had these great free-ranging conversations about consciousness, but in particular about how you could recognize consciousness, how you could study it, and more germane to my immediate interests, how you could study consciousness in non-human animals that could not give you some sort of an accurate verbal report. And so that's the first time around 2004, I think, give or take, roughly to late 2004, that Bernie and I met. And we started sort of meandering about this topic of animal consciousness. And I've been a devotee ever since, I guess, for better or worse. So that's my strange, long story.
I know this question's going to be on the minds of some of my listeners. What's your relationship to Gerald Edeleman?
Aha. Yeah, well, that's not so accidental relationship. I'm his son. Yeah.
It's a sort of a biological relationship.
Kind of, sort of, yeah.
Yeah, I'm going to come back to that later because I'm really interested to, at some point, talk about how his theories of consciousness have interacted with global workspace theory. I have to admit that although I've read some of your father's work, not carefully, and not being a fan of integrated information theory, I really haven't really gotten into that literature. So I want to come back to that if we have time. But I know that today our goal was to focus on global workspace theory and its origins and where it is today. I appreciate that Bernie sent me the latest book, which I think is a compendium of a lot of your work. Is that right, Bernie?
Yes, exactly.
Bernie, can you tell us what it was like to try to explore consciousness in the early days of your career?
At the time, behaviorism was very much a governing thing. And George Miller, one of my favorites, later on wrote that basically you wouldn't get a job in academic psychology if you did not say you were a behaviorist. So naturally, being somewhat suicidally inclined, I started to talk about consciousness. I guess I couldn't stop myself. And of course, consciousness is the original meaning of psychology. And I now understand from Greek scholar that Aristotle's book, sometimes translated into English as On the Soul, that it should really be translated on the biopsychology of consciousness. And I'm only making up a little bit of that. It's mostly true. And that's very interesting. And it's not that surprising because there's all kinds of ancient philosophical traditions, of course, that are very focused on consciousness in its various aspects. And Aristotle was, in so many ways, the founder of half of Western philosophy, the other half being Plato. And Aristotle was a naturalist. He was an observer. And whenever they had a debate, which was pretty much all the time, about whether observation was more important or whether ideas were more important, Aristotle would become the naturalist. And he was a very, very great mind. It's also true, of course, that that we all pick up tremendous amount of stuff from other people. Much of it we don't even realize we're picking up. So Aristotle represented the best of Western thought, you could say, around 500 BC. And if you go back to that book, it is perfectly readable if you have a decent translation, and everything he says is basically true. So when my friend Natalie Geld and I finished the latest attempt to put it all into a single book, and we called it On Consciousness, I suddenly realized, this was all unconscious, of course, I suddenly realized that this was the title of Aristotle's book. So we're back to 25 centuries ago, and that's one of the ironies of this field, that it did not start with the behaviorists in 1912. It didn't even start with William James whenever he started to think seriously about these things, which was very early. It did not start in a huge tradition in India and China and European philosophy. It started a lot earlier than that, so early that we're only guessing, basically, about if there are such things as origins, which is what David is interested in.
I want to interrupt here. One thing about Aristotle, though, didn't he think that the mind was in the heart instead of the brain?
That's a very interesting thing, yes. And I have a hypothesis about that, which I think is interesting. And the hypothesis has to do with a part of cortex that's called the insula, which means island. The front half of the insula appears to be the place where we have internal feelings, like emotional feelings of love and hate and fear and so on, but also feelings of nausea and so on. That is the part of the brain that we attribute to the heart. So around the world, as far as I know, there are people who talk about my heart says such and such. And when people in India say namaste, they very often gesture to the heart. So that's all very interesting. But I think it's one of those feelings that are referred to a part of the body where the actual feelings are not activated, or I should say, far away from the neural basis of those feelings. Let me just say it that way.
Well, that makes sense. I mean, like we feel pain in our toe, but that's also in our brain.
Right, exactly right. And that's a very hard thing for many people to get. I sort of understand it, but as far as I understand the science today, and David will agree or disagree as he chooses to, as far as I understand it today, the cortex is the organ of consciousness, as Penfield said in 1934. And he knew because he was talking with epileptic patients who were awake and conscious while they were having their cortex stimulated with a little bit of electrical voltage. And they would talk about their experiences. And he came to believe after a while that cortex had to have something to do with consciousness. In any case, you're right. In a real sense, all of our conscious experiences are in our heads, and we project them, and we also, very often, we know them to be in our toes. At some point, I talked myself out of behaviorism. And at that point, of course, it was obvious that the most taboo subject of behaviorism was the biggest gap in the literature, at least in the behavioristic literature. There was a little bit on it, but not very much. There was some physiology on it, of course, and brain work. And I knew about Penfield, but I should have known a lot more about Penfield because I did not pay enough attention to all this wonderful work that he did on what turned out to be 1,200 epileptic surgical patients. So he had plenty of time to replicate his results. Just this huge stream of patients in Montreal at the Montreal Neurological Institute. Anyway, so I failed to do my homework as well as I should have done, but over time I did rediscover a great deal of it. There's a tremendous amount of very fine evidence on that topic, by the way.
I want to take a moment to remind you to check out my favorite app, Text Expander. It allows you to get time back by saving repetitive typing and avoiding mistakes. You create snippets for things that you type over and over again, and this really saves a lot of time. It helps you stay consistent and accurate, and you can include anything from text to images in your snippets. Text Expander is available for Mac, Windows, Chrome, iPhone, and iPad. All you have to do is visit textexpander.com/podcast for 20% off your first year. That's textexpander.com/podcast. And don't forget to tell them that you heard about it on Brain Science.
So about the time when I liberated myself by committing professional suicide.
What year was that?
That was 1980, actually. And there were other people who were ready to catch me as I fell into the street. And they were wonderful. There were people at UCSD, as a matter of fact, who had created something called the Center for Human Information Processing. And I was there for a year, and we had all these weird scholars walking around having their own thoughts and occasionally trying to communicate them with other people. And they were the neural net pioneers, for example, Jay McLellan, David Rumelhart. Donald Norman was a really important person at that time, George Mandler also. And they, of course, represented the tip of the iceberg because what they, in a sense, represented was the feeling of dissatisfaction that so many people had had from the feeling of being hogtied by these arbitrary seeming constraints on the language we were supposed to use and on the evidence we were allowed to collect. One of the really important things that happened around that time was the cognitive architecture tradition started to really flourish. Cognitive architecture being sort of computer models, AI type models of what the human mind was like. And when I started to look at that literature in greater detail, I started to realize that ever since the 1950s, when people started to build these computer models, all these models had this very weird feature. They had an enormous memory, and they had a tiny, tiny little processing capacity. So there were tiny rivers running through this great swamp. And they pretty much all had the same feature, which was very puzzling. Alan Newell, I think, had the very deep insight that what we were doing was looking at things upside down. That what we should be doing is, in a sense, asking the question, why is this very limited capacity little rivulet, as James called it, why is it running through this enormous meadow of what we might call long-term memory or memory period? It's not just memory, it's also a bunch of automatic processes that we have learned and so on, everything down to eye movement control, for example, which is largely unconscious. So this is really an old question, of course, because people have thought about these things for such a long time. Sigmund Freud, at one point, when he was trying to figure out what was going on, basically suggested that perception was serial and that memory was this enormous archive of what we would call parallel processing. It's sort of embarrassing to say we didn't really understand much about the brain, period. And one reason why I think we didn't understand much is that we all were unconsciously influenced by the computer model. And the computers at that time were digital computers that basically ran formulae. So Fortran is formula translation. And other than math and logic, all it does is control the flow of information. So it's kind of a flowchart thing plus math and logic. And that was the natural thing to do, of course, because those were the formalisms that were easily translated into computers. So we tended to think about computation as very expensive, very demanding in what David might call metabolically.
I think we have to sort of fall back a bit and consider the idea that we're talking about a human invention versus, of course, biology, versus the natural world, versus what evolution can shape up. And in terms of human invention, what we frequently do, especially if we're great fans of logic, as we are wont to be, whether we know it or not, being humans thinking with a human brain and speaking with language and writing and et cetera, et cetera, et cetera, logic is very constraining, right? So a logic circuit is hyper constrained. And you have to consider, and of course, I think Bernie would go along with this, the very earliest computers, even to the present day, computers are point-to-point wired. They're essentially very discrete systems. One thing wires to another, and if you sort of shunt off one bit of that wiring to something else, you're screwed, in a sense. Right. The thing is not going to work really well. So this is in contrast to biology, where over the course of development, we can demonstrate quite beautifully from fruit flies on up, that in the process of development, neural circuitry, even neural circuitry in so-called twins, even in human twins, diverges quite considerably. It's never quite the same. And with very few exceptions, perhaps olfaction, the sense of smell, is the exception, there's very little in the way of simple point-to-point wiring in the nervous system, in the biology. That is to be distinguished quite poignantly from a digital computer, from first what, say, Alan Turing had in mind in Colossus and all of the effort at Bletchley Park to break the Enigma codes, on to ENIAC in the basement of the University of Pennsylvania's engineering department, on up until the present day. If you look at computer hardware, it's still a really different thing than a so-called biological or neurobiological circuit. The discreteness is quite artificial and quite a paragon of human invention, but it's very much to be distinguished from biology.
So I want to just return to the global workspace theory. you're telling me about the context in which it arose, which was in a time when people were beginning to imagine that the brain might work something like a computer. And what I'm hearing you say is that in some ways this constrained our imaginations about how our brains might really be working.
Right, absolutely. And so what happened with Alan Newell in particular, that after 50 years of trying to simulate human problem solving in the cognitive architecture tradition, which is basically AI, he started to realize, I'm sure with other people as well, that we had things sort of backwards, that the very narrow serial protocols that he collected from chess players, for example, where chess players are very good very often at describing their mental processes and going from move to move, but also in recognizing entire gestalts, entire patterns of pieces that ring a bell for them. So they might be able to sense a threat from the opposing player without quite knowing how to describe it, because they build up intuitions, as all of us do, of course. And Newell, I think, began to realize that the protocols, the verbal protocols he collected, which were the conscious thoughts of the chess players, that they were, in a sense, the smallest part of what was going on. And that this giant unconscious collection of information processors, including memories and automatisms and intuitions and all those kinds of things, that's where the action was happening. And he had a very specific challenge to cope with, coming from, at that time, the Advanced Research Projects Agency called ARPA. It's now called DARPA, but it's basically the same thing. And DARPA had a problem, just to tell the story, of how do I build a computer that's not going to be destructible via a nuclear weapon or some other local disruption.
And that's what led to the internet, right?
Exactly right, yes. And the answer was the internet, because the internet, supposedly, you could rip half of it down and the other half would take over, which is precisely how the cortex recovers from damage, by the way.
I want to take a moment to introduce our new show sponsor, the Neurology Minute. The Neurology Minute delivers 1 to 2 minute daily briefings of what you need to know in the field of neurology. The latest science focused on the brain and timely topics explored by leading neurologists and neuroscientists. The Neurology Minute is from the American Academy of Neurology, with contributions by experts from the neurology journals Neurology Today, Continuum, and more. Subscribe to the Neurology Minute wherever you get your podcasts, or visit aan.com/podcasts for more information about the show.
Brain damage cases like Phineas Gage are not uncommon historically. They're not necessarily common either, but they happen, and they happen in sufficient numbers so that we know that you can do an astonishing amount of damage to the cortex without permanent loss of function. And so the network notion is very attractive there, because if you look at the network at a spider web, for example, it is also a kind of hyperstable organic product where it can get ripped one way or another, and this spider will go and fix it, perhaps even be able to use it with its hair. Alan Newell came up with and was able to show through a project on speech recognition was that you could have all kinds of little processors that would work together and compete or cooperate with each other. And as long as they had a common space, a common blackboard that was called the Global Workspace by Newell, by which they could interact with each other. So the intelligence was really in the unconscious little mechanisms. It's like the game of charades, really. The common intelligence of a dozen people sitting in the same room is greater than the individual intelligence of perhaps even the smartest person, or let's say the most verbally talented person sitting in the room. And that's the principle that led to the World Wide Web, and which is now constantly in use by various corporations, governments, and so on.
So your global workspace theory was, at least in some sense, inspired by his use of the term global workspace?
Yeah, it certainly was. And I think what I added to it is the taboo term, consciousness, because William James, for example, was always talking about the stream of consciousness. And stream of consciousness literature, of course, was a very, very important product of that time, around 1900, a little before, a little afterwards. Marcel Proust, any number of really talented people who were novelists, right? So they didn't have a taboo against, observing their own thoughts. All of them, or many of them, did extremely important and very creative work. So the idea of a narrow stream surrounded by this huge meadow was fundamental. It was very well known by the Jameses, Henry James and William James, and by many, many other novelists of the time. It was kind of cliche, but it wasn't a cliche in 1980, at least not among people who thought they were doing psychology and who kept on bumping into the very same phenomenon.
A recent book by Joseph Ledoux listed at least 20 different theories about consciousness. I want to talk about the relationship between global workspace theory and global neuronal workspace theory. But before I do, I'm going to ask David to give us a review of the key ideas of global workspace theory.
Sure. So to start with, it sort of helps to understand really, really briefly the historical context. So when Bernie started to think about this sort of an issue, the nature of consciousness, he was inspired by the work of folks like Alan Newell, who had done a lot of research into language comprehension in basically sort of early what you might call AI systems, the idea of some sort of an algorithm that was running on some deeply parallel processing machine that could come up with a way to understand, get a distinction between one word and another. So essentially the problem of language comprehension. And they didn't have much luck, but what Bernie got from this is the idea that perhaps we should sort of look at the brain, the central nervous system, as a series of essentially non-conscious processes that are sort of running on their own, and reconcile that with the idea of consciousness being, as far as we can tell experimentally, a single stream. The idea that you can only be aware essentially of one percept at a time, one unified entity at a time. And you have to reconcile that with this seemingly vast memory store that you have. So you can access all kinds of stuff. You can't do it all at once consciously. So Bernie sort of started with that idea, and he came up with the global workspace. And so the idea behind the global workspace is that essentially you have this sort of a broadcasting function going on in the brain. So you have this large, really vast distributed collection of specialized networks in the cortex. And these networks that are running these different processes aren't in and of themselves conscious. But at some point, somehow, there's sort of a broadcast phase that gets entered into, and this sort of evokes sort of a widespread synchrony. It sort of brings everybody together. And so you're talking about sort of, in a way, to go back to a very old analogy to sort of a theater, not the Cartesian theater, mind you, not anything that folks like Daniel Dennett talked about very early on, but the idea of a theater containing an audience of very specialized folks that have specialized different sort of knowledge sources. And at some point, there's a global signal that triggers some sort of reentrant mapping that triggers some sort of a temporal synchrony of these things, and there's sort of a resonance, and that resonance is sort of the processual fabric of waking consciousness. So that's a brief summary.
In most of the literature that I've read recently, they usually talk about global neuronal workspace theory as an outgrowth of your theory. Do you mind talking a little bit about how you see the relationships between those? Do you think it's like the difference between a psychological theory and a neuroscience theory, or it's just a growth? How do you see that?
I don't think it is anymore. And David and I have talked about this actually fairly recently. And I started to talk myself into the idea that there's really two kinds of theory, and only two kinds of theory. And one kind is psychobiological. That is to say, it's based on psychological observations such as short-term memory and visual consciousness and selective attention, vis-a-vis the enormous unconscious memory domain. And that's the psychobiological theory, and everybody, in a sense, has to deal with that if they struggle with the facts of psychology and biology. That's one kind. And Stendhal and Jean-Pierre Changeux are both wonderful. They have done really terrific work on that aspect using very, very good brain imaging, and recently very high-resolution work on what's happening in the visual cortex when you run an experiment on visual consciousness, basically. And then you have another set of theories that I never know how to talk about it, because I like the people who get involved with these kinds of things are very smart, but I never understand them because, at least to my knowledge, they never quite tie things, they never quite anchor things to empirical evidence. And so I just wave my hands at it and say, geez, that's interesting. I don't know what it means.
I would say, and forgive me if I take any liberties here, but I would say the main distinction between Global Workspace and Global Neuronal Workspace, as laid out by Jean-Pierre and Stan, is they're essentially putting sort of neurophysiological teeth on your idea. There's no real distinction in terms of the overall construct, right? If you had to sort of wave your hands as best you could and explain it, more or less the gestalt would look quite similar, more or less the same.
Oh, sure.
It's just that they're describing, in the context of some neurophysiological evidence, the machinations, what's actually sort of happening if you sort of take a functional snapshot, what's going on there. And that's the distinction that I would make. Does that sound reasonable, Bernie?
Yeah, the only syllable I would disagree with is I think they have psychophysiological evidence.
Okay. Oh, no, that's fair enough, of course. Oh, yeah, because they're using, in a sense, some of what they do goes back to old-fashioned psychophysics, but what they are using tried and true methodology that tease out behaviors from subjects, but they're also mapping sort of all of the intrinsic stuff along with that, right? So
right. And that's exactly the reason why I seem to agree with about 75% of the people who are doing work that I know something about, who are all essentially doing the same thing in different creative and productive ways.
Sure.
This guy named Stephen Grossberg, who's doing very interesting work in modeling single cortical columns. Mm-hmm. And so there's a ton of stuff going on. And of course, if you really look at the larger literature on cortex, which goes back 25 centuries, it's enormous and it's tremendously important. Mm-hmm. So it's not as if we started this yesterday.
Right.
And then there are the other theories that I don't claim to have an understanding of.
In terms of your looking at the world in terms of the two kinds of theories, it sort of reminds me of the difference between Aristotle and Plato, right? Because Plato was all about the ideas. They were like a separate thing of their own reality. And some of these theories are like that. They're, like you say, they're not tied to anything. They're not grounded. So it's interesting that those two ways of looking at the world, we seem to have been almost inherited them. They just keep on keeping on.
Yeah, I think that's right.
Absolutely, yes.
I think maybe that's an offshoot of the tendency of the human imagination to do what it does, right? If you do a survey of everything from great art, so-called, and music into even certain aspects of hard science, and in particular, speaking to what Bernie mentioned as all the other theories that he has a hard time grappling with, as do I, the physics entree in particular to consciousness science, and I'm not going to mention names, I won't name names here, but the notion that they're taking aspects of physics as they understand it and instantiating what they think the conscious process is on this very fine, very, very sort of hyper small level of interactions, which may or may not have anything. It's sort of spooky, right? And that's a pregnant term in this area. But those interactions may or may not have anything. Well, ultimately, of course, quantum interactions must have something to do with whatever the brain is doing in terms of function. But if you're asking me whether they have anything explicitly to do with consciousness per se, there are so many levels of interaction between the very small stuff that quantum folks are describing and what's going on and what I see or what I think of as conscious processing, i.e., the firing of neurons, et cetera, in discrete, or not so discrete, but patterns. It's a kind of a non-starter to me because I don't see and I think echoing what Bernie would say, I don't see what their hard evidence really is other than, these structures are consonant with bits and bytes and the architecture of computing machines. Well, that doesn't tell me a lot. That certainly doesn't provide me proof that there's a link between quantum processes and, say, microtubules and what we're doing when we're aware of the world in some way, shape, or form. There's a disconnect to me.
And most physicists reject those theories, too. I mean, last year when I was doing a series on consciousness, one of the people who I featured, I didn't interview him, but I featured his work, was Sean Carroll, because not in his most recent book, but the one before it, he talks specifically about why this is a non-starter. One of the things is temperature.
Yeah, there are constraints.
The brains are way too hot for that stuff to be going on.
Yes.
Yeah.
I have to admit that as much as I try to feature consciousness on this show, I've probably limited the theories that I feature to, definitely to ones that fit into the category of having some empirical evidence behind them. Is there anything else that's going on right now that you're really excited about, Bernie?
There's too much. Again, if you go to PubMed and type in conscious and brain, you've got 10,000 articles coming up or whatever. And I feel very bad, actually, because I cannot keep up with the stuff that I would like to keep up with, which makes these podcasts all the more important, by the way, because we need more people to really think in depth and to read serious articles and so on.
Nothing in particular that floats. Is there anything that floats your boat, though, in terms of a trend? It can be experiments, or it can be who's doing some really cool work that maybe dovetails in with your thinking.
I love the connectome. And the connectome is sort of the street map, the structural street map of Cortex. And I think this is consistent with neural Darwinism and other biologically inspired theories. What consciousness apparently has to do with is not the structure so much, but the flow of information in Cortex, also outside of Cortex, but the crucial, in respect to subjectivity, the crucial area seems to be the cortex. So what we need is a flow conception of neuronal communication in some form that's testable. And that's not an impossible challenge, I think.
And this is really interesting that you bring this up because, I don't want to dwell on the history at all really at this point because we've gone through that pretty well chapter and verse, but it harkens back to something William James said in his wisdom a long, long time ago, which is essentially consciousness is process, not thing. That's not an exact quote, of course, but it's a very important concept because when you invoke that concept, I think you all but eliminate a lot of those weird, sort of spooky ideas on the fringe, because a lot of them are dwelling inevitably, especially if they fall back on computer structure. I'm not talking about architecture, because architecture can also be process. But if they fall back on structure, they're almost sort of implicitly saying sometimes that, oh, what they're talking about is a thing. Well, consciousness is the traffic patterns. It's the flow. It's the stuff that's going on among and between clustered groups of neurons that we call brain areas in some cases, you know. And that's really important because you can kind of eliminate the chaff for the wheat if you sort of start with that idea.
So I want to ask both of you this question that I usually ask my guests, because I do have quite a few students that listen. Advice for students who, now you can study consciousness, but that's an awfully big area. Do you have any advice about how one would get started?
That's a tough one.
I'm a student sitting in your office. What are you going to tell me?
I would ask you, what are you most interested in? Just like any professor would ask a student, right? I'm somehow thinking of the late Jaak Panksepp, who was a very great pioneer in the neuroscience of emotion.
I had him on several times.
Yeah. And Jaak spent, I think, maybe the last 10 years of his life on the question of animal suffering in the context of farms and so on, and whether that could be relieved to some extent. And I believe that there have been real improvements in that area. That's a very important one because it mixes, of course, the ethical and moral aspects of consciousness with the science.
I think what I would say to a student would be focus on a particular aspect of sensation to begin with and choose wisely. If you choose vision, I won't say the world is your oyster, but there are an awful lot of folks there that are toiling in the vineyards of vision science, and they're doing some pretty cool stuff. You have a lot of potential advisors to choose from if you choose that area. You don't have to be constrained by that necessarily. You could choose olfaction. The beauty of sort of narrowing it down to a sense is you won't necessarily totally torpedo your career early on by worrying about turning out papers on consciousness initially. You can start by turning out papers that are very elementary in the sense of pinning down the attributes of, say, visual perception or how the brain picks apart visual stimuli. And that's a good start because that inevitably, if you are still interested in consciousness when you go on down that track, you can at least get traction. You can get a foothold in the field and publish a lot of really cool things, do a lot of really cool research that doesn't necessarily have the big C in it, that doesn't have the word consciousness in it, but it can inevitably lead that way if you so choose. So that gives you flexibility. And my second bit of practical advice to any student, and I don't care what area of neuroscience you go into, but this is particularly important for neuroscience, is choose your potential mentor / advisor wisely. Don't go in blind. I've been there. I've done that. It's not a good thing to do. So get to know the folks who are actually working in the area. And when I say get to know them, I mean, if you can, literally reach out, and you are going to get that opportunity if you're chosen to have an interview or if you're chosen to visit a department in the preparatory stages of your application. Well, take full advantage of it. Talk to as many people as you can. I am including students as well as professors. Talk to graduate students who have a particular professor in mind, who either is their mentor or is somebody who has guided their work. Get as much info in terms of the interpersonal dynamics as possible, because that's going to dictate the rest of your professional life. Inevitably, once you get your PhD, it doesn't end, or it shouldn't end. The man or woman you choose to work with, hopefully is going to be somebody you're going to interact with after that. And it's going to be somebody who can inevitably help you open doors. So those are my two, I guess, pieces of advice to any student dawning my door.
Good deal. And let's hope that these COVID restrictions don't last too long. I mean, I'm in medicine, and so I'm working with kids right now who are picking a residency when you can't go visit the place. It's really a really hard time for students.
Yeah, very tough.
Is there anything else you'd like to talk about before we close? I think we've had a really interesting, freewheeling conversation today.
I've talked myself into thinking that Cortex is the organ of a dynamic version of something like a global workspace. And that converges nicely with neural Darwinism. And in fact, I think we should do a little bit more work on that. David and I, and maybe some other people, on that convergence, because they emerged from different research traditions, but they went the same place, or at least a very similar place.
Right. And I think there is an important link between the work my father did and his theoretical framework and Bernie's. Neural Darwinism, or the theory of neuronal group selection, more properly, it's a pretty broad biologically based theory. But the bottom line is I see it as sort of essentially providing the functional glue that it sort of explains how a global workspace can sort of hold together in that snapshot of time that we call conscious experience. So by the glue, what I mean is the dynamics that my father sort of foresaw in penning neural Darwinism are such that you have different areas in different parts of the brain, quite widely separate, right? But they're nevertheless connected by long distance sort of bidirectional pathways. In essence, it's the signaling within those pathways and between those areas, or between those patterns of activity in different brain regions. It's the signaling that inevitably gets locked in time. There's a temporal locking of those signals together into a sort of a cohort that we might see as a sort of a snapshot of the global workspace in action. I think that's essentially the connection between the two theories. One theory lays out this sort of workspace conception. The other theory basically says, okay, well, this is how you can literally build dynamic representations that sort of cohere, at least within a sort of a finite amount of time. And I think that's really important. That leaves out a lot of the guts of neural Darwinism. And also, to clarify, there's a particular aspect of neural Darwinism contained within the framework called the dynamic core, which is really just explicitly referring to, in this case, cortex and thalamus, and the particular talking that goes on between those two organs of the suborgans of the brain, and that temporal locking within those two areas functionally, that is literally and figuratively at the core of conscious experience. So I think that kind of gives you a snapshot of the complementarity of the two ideas, the two theories.
It was an honor to have Bernaard Baars on Brain Science, and I also enjoyed meeting his friend and colleague, David Edeleman. I want to make a comment about David's unusual career path because I frequently get emails from people who have become fascinated by neuroscience after starting out in totally unrelated fields. David is one of many scientists I have interviewed who found their way into neuroscience via an unusual path. The key idea is that you have to pay your dues, even if that means pursuing low-paying postdoc positions in order to acquire the skills you need. However, the great thing about neuroscience is that those of us outside the field have access to most of the research that is going on. In today's episode, we really didn't talk about any new research, but Dr. Baars gave us an important historical perspective on how behaviorism blocked the scientific study of consciousness for many years. Ironically, when the cognitive revolution broke behaviorism's grip on psychology, the tendency to view the brain as similar to a computer brought its own hazards. David Edeleman touched on this briefly when he pointed out that computers and brains are very different. The basic idea of global workspace theory is that there are many processes going on in the brain, most of which never reach our conscious awareness. But there must be a mechanism that determines which processes reach conscious awareness. Dr. Baars credits Alan Newell with the term global workspace, which was used in the context of his attempt to create a computer simulation of language. Dr. Baars' main goal was to create a testable psychobiological theory of how these processes happen in real brains. If you are interested in more details, I encourage you to read On Consciousness because it provides access to most of his work in a single volume. Many current theories, especially Global Neuronal Workspace Theory, owe their origins, at least in part, to Baars' pioneering work. Whether or not one shares Baars' conviction that the cortex is the organ of consciousness, he has taught us several principles that have stood the test of experimental verification. First, the brain and its connection to the body and the world are essential for the subjective awareness that we call consciousness. The second key idea is that despite our fascination with consciousness, most of what the brain does is unconscious. Unfortunately, we barely talked about the important question of non-human consciousness. If that topic interests you, I strongly urge you to go back and listen to episode 138 with John Mallett, co-author of the book, The Ancient Origins of Consciousness. As always, you can find complete show notes and episode transcripts at brainsciencepodcast.com. And don't forget that Brain Science is produced independently and relies on listeners like you for financial support. You can learn more at brainsciencepodcast.com/donations. Please send me feedback at brainsciencepodcast@gmail.com. Post voice feedback at speakpipe.com/DocArtemis or post comments on the Brain Science Podcast fan page on Facebook. Before I close, I want to remind you about my upcoming live webinar called Embracing Uncertainty, How to Thrive in an Uncertain World. It will be held on November 17th at 4 p.m. Eastern Time. This event is my way of saying thank you to those who bought my book, Are You Sure? The Unconscious Origins of Certainty. There are 3 ways to get a free ticket to this event. One is if you bought Are You Sure? In June 2020. Number 2 is if you post a book review. And third, if you sign up for Patreon at least the $10 a month level. You can learn more about these and get your ticket by going to brainsciencepodcast.com/uncertainty. Brain Science is released on the 4th Friday every month. So until next month, I hope you will share the show with others and check out my other podcasts, Graining Rainbows and Books and Ideas. Thanks again for listening. I look forward to talking with you again very soon. Brain Science is copyright 2020 to Virginia Campbell, MD. You can share this audio with others, but for any other uses or derivatives, please email me at brainsciencepodcast@gmail.com. The theme music for Brain Science is Mindfire, written and performed by Tony Catraccia. You can find his work at syncopationnow.com.